Hi everyone. Today we're going to finish up chapter 11.1 in our textbook, and the title of the section again is Circumference and Arc Length, and we are going to solve real-life problems and find the perimeter of irregular shapes. Alright, so I want you to take a look at this instrument here and think about what this thing actually is and how do you think it works. Okay, so if you answered a distance measuring wheel, you are correct. Now, we've mentioned this in class before. This is a very accurate way to measure distances. And the idea behind it involves this formula here. So that wheel has that wheel has a circumference. It has a distance around the wheel. And every time it spins, that wheel captures how many revolutions it's making. So it takes the wheel's circumference and keeps track of the number of revolutions, and it turns that into a total distance. So down here, I have two formulas that are based on the circumference. So notice that circumference, again, which is just the distance around the circle. We've converted that to our formula that we learned yesterday, 2 pi r. And you can also, of course, use pi times d, because both of those give you the circumference of a circle. And you're going to multiply that by the number of revolutions that the circle makes, and that gives you the distance, this your total distance. Okay, so make sure to write one or both of these formulas. So we're going to use that formula on this example here, and it says that the dimensions of a car tire are shown, and to the nearest foot, how far does each tire travel when it makes 15 revolutions? Alright, so we're going to use the formula distance is equal to pi times diameter times the number of revolutions. And as you can see here, we can get the diameter by adding up these three numbers. The 19-inch is the size of the rim itself, plus the 3 inches from the tire on each side. And that gives us a diameter of 25 inches. So that's what we're going to plug in, 25 for our diameter. And as the problem stated above, we have 15 revolutions. So we're going to go ahead and multiply that. And we're going to just try not to round it to the very, very end. So that's why I wrote the entire number in that form, 1,178.0972451 inches, because the diameter was in inches. But if you look closely, the problem does state we want to find the distance to the nearest foot. Okay, so that means we're going to have to convert our inches to feet. So to do that, I'm going to use something that I borrowed from your chemistry class. For those of you that have already taken it, you might be familiar with this. It's called a T-chart. And I'm going to take our distance of 1,178.0972451 inches, and I'm going to put the conversion on the other side here. And the conversion says it's 12 inches and 1 foot. All right, we want those inches to cancel out, which they do. So 1,178 times 1 divided by 12 is approximately 98. And again, that's to the nearest foot. So we are now going to round at the very end of the calculation. And that's why I left all these numbers here, because again, if you round too early, you can affect your final answer. And this rounds to a whole number of 98. All right, so please pause the slide and give this problem a try and check back once you're finished. All right, so the radius of the wheels on this bicycle are 33 centimeters. To the nearest meter, how far does the bike travel when it makes 100 revolutions? So before I show you the solution, you are given the radius, and that r is 33. So If you'd like to turn that into diameter already, you can just take 2 times 33 and make that 66, right? And you're also given that there's 100 revolutions. And by the way, the radius is given in centimeters, and the problem says we want the final answer to the nearest meter. All right. So here's the solution. The radius is 33. So I use the 2 pi r times revolutions formula. And I plugged in 33. 33 times 2 is 66. So you could have just used pi times 66 times 100 if you'd like. Here's our distance in centimeters. Now, you may have to look up the conversion. You may have to go online, Google, and just write, how many centimeters in a meter. And the conversion that I used here was 100 centimeters in 1 meter. So on my T chart, I wrote out 20,734.511, etc. centimeters, and I put the conversion from meters to 100 centimeters. That cancels out my centimeters. So basically, I'm dividing 100 into this answer here. This divided by 100 gives us approximately 207 meters to the nearest whole meter. All right, for our next example, we are going to find the distance, or in other words, think of it as the perimeter. The perimeter around the inner lane of the track. So what I mean by that is just this inner lane. Like if we were running right on top of that line of the track, what would be the perimeter? All right, so here's how I want you guys to approach this, because there are no revolutions in this type of problem. We are going to find the distance by taking 2 times the length of each straight section. What do I mean by that? Well, there's these 2 straight sections that you would run if you were a runner on this track. So you've got those 2 straight portions. And then you've got 2 semicircles. So you would be running at a you'd be curving around the track, and you curve twice for each semicircle. If you want to think of this as the length of one circle, that would work as well. Okay, if that makes it easier for you, you can just add the length of one full circle. All right, now the 2 straight sections are 84.39 meters each, so I'm going to multiply that by 2. The length of each semicircle is, so the circumference of a full circle is 2 pi r, and you only have half of this. So 1/2 times 2 pi r, and then you have 2 semicircles. Now again, if you treat this as one full circle, you wouldn't have to worry about any of that. Those cancel out too, by the way, anyway. So you can add 2 pi r, or you can just add pi d, because that's equivalent. In either case, you are going to get 229.3362637 for this calculation here on the right. And that should be the same regardless of how you do it. All right, and on the left, 168.78. Remember, I'm trying not to round to the very, very end. When I add these 2 values up, I get an answer of approximately 398.12 meters. Okay, so a lot of you cross-country or track runners know this. This is the 400-meter race. And yes, it's not exactly 400, but that's because we were calculating the perimeter as if you were stepping on the line. In reality, a runner would not be on the line. They'd be a little bit off of it. So that would come out to be about 400. But answering this question the way that it was asked gives you 398.12 meters to the nearest hundredth. Okay, pause the video and try this one out. So this is a little different, but I want you guys to give it a shot on your own and check back in about a minute for the solution when you're all done. Okay, so here you should have gotten an answer of a solution of 36.57 millimeters for the perimeter. So let's quickly talk about why. You have 3 straight sections here, and they are all congruent. Now, if I were to close this off, they gave us the radius of that semicircle. I'd have another 4, which means that this is 8. So that means I've got 8 millimeters around the 3 sides of that. Well, it's not a square, but it's 3 parts of a square, it looks like. So that's where we get 24, 8 plus 8 plus 8, or 3 times 8. Now, you want to get the length of this half or semicircle. What is the distance around that portion there? All right, so here is the circumference, which is basically the perimeter of a circle, is 2 pi r. So that's 2 pi times a radius of 4. And it is a semi or half circle. So you're going to have to take 1/2 of what you normally would have. That would actually just be pi r for short. But, just be careful with shortcuts. No matter which way you do it, you should get about 12.56637061. And when you add that to 24, you get 36.57 millimeters to the nearest hundredths. All right, one more problem that I want you guys to try, and we will go over the solution. So here, I want you to pause the video and try to find the perimeter of the shaded region. So by that, you're going to get this turn here, this straight portion, this turn there, and then this straight portion. All right, please pause the video and check back when you're done for the solution. All right, so here, notice this problem is identical to the track problem. So think of it like this. It's almost identical to the one on the track. Instead of running outwards, this person is running inwards. So if you were running on this, if you thought of this as a track, you'd have a straight section here, and then you'd turn inwards, and then you'd have another straight section, and then you'd turn inwards again. And again, that's identical to a track, that track problem that we did. Okay, so with that said, you have 2 straight sections that are 15 units apiece, which gives you 30. You have 2 semicircles. Now, if you look at the way the 9 is placed, that is right in the center, which means the radius is 4.5. So here, 2 pi r, 2 times pi times 4.5. And again, if you realize that you basically just want one circle, you could ignore this, and that does cancel out. But just be very careful with shortcuts. Regardless of how you figure that out, you should get about 28.2743338, and that will give us a final answer of 58.27 units. All right, so that concludes our lesson. If you have any questions, please send me a Schoology message or Google Classroom message, and I will get back to you as soon as I can. Have a great day, everyone.